welcome back to another explainer. There's a challenge we all hit eventually as developers and designers. You've got a dashboard, right? And usually it's just this boring, static wall of numbers. So how do we take that and actually transform it into a living, dynamic data display? Well, today, we're popping the hood on a component that does exactly that, the B4XDaisyInfoCard. We're going to dive right into the source code and see exactly how this thing brings data to life. Here's our roadmap for this explainer. First, we'll meet the InfoCard itself. Then we'll explore its different layout families. After that, we'll look at styling it with visual variants, dissect that awesome count-up animation, and wrap up by checking out its interactive touch effects. Let's get into it. Starting off with Section 1, meet the B4XDaisyInfoCard, the ultimate data solution. Standard user interfaces usually just demand passive observation, right? You just stare at a number on a screen and that's it. But the core philosophy behind this info card is entirely different. It's designed to be a living dashboard where data literally counts up to its target. By injecting motion and contextual color directly into the data itself, we're totally flipping the script. We're turning the user experience from just passive observation into active, satisfying engagement. Okay, to get that living experience, we've got to start with the bones. Section 2, exploring the layout families, the structural foundation. Let's dive right in by looking at the stark visual differences between the layouts provided in the source code. You'll notice the various types grouped together. Up top, in what the code calls Family A, we've got layouts heavily featuring an icon on the left. Type 1 has this very bold, solid-colored column holding the icon, while Type 2 opts for a much more subtle, lighter column. Then, as we move down to Type 4 and Type 5, we enter Family B, and these actually abandon that left column entirely. Instead, they use this beautiful, oversized watermark icon situated delicately in the background on the right. It's a totally different vibe. Now, what's truly amazing from an engineering perspective is just how effortless this structure is to implement. You literally change a single designer property in the code, an integer called InfoType, and it completely dictates the skeleton of the card. Setting it to 1, 2, or 3 gives you that Family A icon left look. Pop in a 4 or 5, and it switches the layout logic over to the Family B watermark style. Oh, and there's even a Type 6 for a badge card variant. But here's the best part. Binding all of these layouts together is a shared helper function in the code that applies a consistent 16-dip rounded card surface. That ensures perfect scaling across devices. So, no matter which layout family you actually choose, the whole dashboard looks incredibly cohesive and modern. So, with our skeleton in place, let's move on to Section 3, styling with visual variants, where we start painting the skin of our UI. Once we have that skeleton, we really need to inject some context and meaning. Think about a purple new signups card versus a red refunds card. In UI design, color is communication. You don't even have to read the word refunds to know that a red downward arrow signifies something needing attention or maybe carries a bit of a negative connotation. Conversely, that vibrant purple accent immediately communicates a primary positive metric. It just clicks in your brain right away. The crucial takeaway here is how simply applying one of these predefined strings seamlessly integrates the card into your app's broader color theme. By setting the variant property to primary, success, error, or neutral, the underlying code just automatically resolves the correct background and icon colors. It actually grabs the exact hex codes right from your app's global design tokens. That means your info cards are always going to perfectly match your app's unique color palette, all without you having to manually code individual color values for every single card. Talk about a time saver. Which brings us to the absolute most dynamic part, Section 4, the count-up animation. This is truly the heartbeat of the card. Just imagine loading up a dashboard and seeing a massive, static target value instantly pop up, say 45,678. I mean, it's informative, sure, but it's completely lifeless. So, how can we make reaching this number feel like an actual event? How do we give the user a real sense of scale and momentum? Let's break down how this is built in the backend logic, because the animation lifecycle here is absolutely brilliant. Step 1, you set a start from value. Usually you just use 0. Step 2, you define a duration in seconds, let's say 2 seconds. Now, when the card loads, Step 3 kicks in. A timer starts ticking rapidly, calculating the elapsed time. But here is the genius part. It doesn't just count up linearly, because that would look super robotic. Instead, Step 4 applies an ease-out cubic mathematical motion. Basically, this means the numbers spin up incredibly fast at first and then smoothly and naturally decelerate as they ease into that final target number. It beautifully mimics real-world physics. And during that high-speed animation loop, properties like prefixes, suffixes, and grouping combine to flawlessly format your data on the fly. Because the number is literally constantly changing during that 2-second animation, the format value code has to work perfectly in real time. Whether you need a $ prefix, a percentage suffix, exactly 2 decimal places, or comma separators for the thousands, the code applies all these formatting rules at every single tick of the animation loop. The end result? A silky smooth, perfectly formatted ticker. It's like magic. Finally, let's look at what happens when the user actually touches the glass. Section 5, Interactive Touch Effects, making it react. Notice the stark contrast between the passive default state and the reactive hover zoom effect that gets triggered upon touch. You see, a living UI isn't just about animation when the page loads, it's about tactile feedback. When a user taps the info card, the component's touch handler intercepts the action. If the hover zoom effect is enabled, it immediately drops the icon's alpha opacity down to 0.4. This instantaneous visual change gives the user immediate confirmation that, yep, their press was registered by the system. But it goes even further than a simple opacity drop. The code actually triggers a material-style ripple. Think of it like a wave effect that originates exactly at the specific X and Y coordinates where the user's finger touched the screen. It echoes outward with a really subtle 25% opacity overlay, creating this highly satisfying tactile feel. Furthermore, lifting the finger can trigger a click event that, as we see in the demo code, can launch a global toast alert confirming the data. And honestly, even cooler, it can automatically restart that beautiful count-up animation entirely from scratch. It takes basic data consumption and turns it into a highly interactive loop. And that brings us to our conclusion, building the living dashboard. We've seen how the B4XDaisyInfoCard solves the static data problem. We explored the ease of switching between distinct layout families, from those solid columns to the subtle watermarks. We looked at how assigning simple string variants instantly paints the card with contextual theme colors. We uncovered the math behind the ease-out cubic count-up animation that literally breathes life into numbers. And finally, we saw how ripple effects and opacity changes create a genuinely satisfying tactile user experience. So, I'm going to leave you with this final thought to ponder today. Armed with the understanding of these UI components and seeing firsthand just how easy it is to implement motion, color context, and touch feedback, what mundane dashboard data will you transform into a dynamic, living experience next? Thanks for hanging out with me on this explainer, and hey, happy building!